All right. Hopefully my computer doesn't die. We don't need much performance, but I'm running OBS and Discord at the same time. All right. Start at 7:15 in 2 minutes.
Just enough time to make sure my machine can boot and have I manually disconnect the battery.
All right. Everybody's here. So I want to start this journey from the introduction to computer and command line, and we're gonna start from the very beginner. And I try to make it that so there's no prerequisite, and anybody should be able to understand and come from today's session with a deeper understanding how computer does its magic. From a very fundamental principle. So it's probably not going to be long, so it's probably 30 minutes lecture, throughout which we're going to look at the fundamental how CPU works and how computer programs are made and executed on that CPU, and then we're going to look at the command line, what it's used for, and we're going to do I will show you some of the live examples that we can mess around, what you can do with a command line that is useful immediately for you, and then we're gonna try to do it ourselves. So I'm here to help. That's an overview of today. So yeah, introduction on computer. I always like to start a story with my personal story.
Oh my God, little Keith.
Yeah.
Oh my God.
That'll be funny. Hair, first of all.
Uh-huh.
So is it really hot?
Live change.
He still has his shirt off.
Yeah,
He's
always
still
the-
That might be winter. In Russian apartments, it's always hot. So
Are you wearing hot pink there?
hot pink shorts. Remember
Yeah,
those?
You always like the color.
Yeah.
Yeah. Where's your weightlifting?
So that's my like room for a while, and Omsk, Russia, and this is my computer. I got computer relatively late. I was like 15 years old where I get this computer. Actually, my sister got this computer who was 8 years older than me, and she like needed for a school because she was graduating from university, and she's like, oh yeah, I need this computer, because my parents would never get it. It was like, what is this machine? What do you do with it? You know, they didn't really understand. So she got this computer for like, there's a printer, she can print her thing. But like, I immediately was kind of like excited, fascinating. And my favorite apps were like, I would open Microsoft Word and like mess around with the things, or like Microsoft Excel and mess out with spreadsheet. And I also like the Windows Paint and that kind of stuff. And the games,
Hell
of
yeah.
course. One of the first game was Grand Theft Auto, first part, I think, top-down view. And Counter-Strike, I think in one of the second photo, I'm actually playing Counter-Strike there.
Nice.
So I'm actually not doing any like, and I think my story is important because it's actually a story. I always been an artist. I never been a technical person. So which might not come out this way today, because I sort of dig into the topic deep, and you know, I got into programming and a lot more like a technical stuff and deep understanding of computer systems. So I was playing with that stuff, and then someday I actually broke my leg and was at home for like 3 months during the summer. And my dad, I don't know why, but he came with a CD, and he's like, oh, I have the CD for you with 3D Studio Max, which was a pirated version of 3D Studio Max. Like any software in Russia, it's like pirated. Like you go on the market, you buy Windows CD for $3, and it'll be like a Windows with a crack. And that's, I actually thought that this how software is made, like meant to be. It's like a software and you crack it. So until I like went to United States and I discovered like, oh, there's actually people making software, you have to pay for it. And so I've been like messing around with 3ds Max, so it's like really fascinating that you can like do this 3D object in shape and hit the render and it create this cool shape. So later I went to study civil engineering in my university. In my university, all of my friends were studying in architectural department, and they needed to do a lot of architectural visualization, buildings and stuff, and none of them knew how to do it because our university didn't really teach that. And so I was like, yeah, I think I can do it. And I started doing things for my friends, like just a little visualization. At some point, even like start charging because there's too many of them who want to do it. I was like, oh, yeah, this is interesting. But my mom would always look at me and she would be like, oh, what are you doing, like wasting your time, like playing with stuff, you know? And later on, it turns out that that's the thing you want to be doing. But I never was technical. I would just press button on the software and I like, just look at the interface. I was always bad at reading. I was terrible at math at school. I failed all the math classes and pretty much like approaching it from the art perspective. And I studied some painting, like on the private courses. I really enjoy that type of work. And I did not enjoy working with text. I did not enjoy doing math or any type of stuff. But through that like computer fascination, I always be like, how does it actually do it? But I could not quite figure out because I didn't have skill. And that was until I got my first job. I went to Moscow, capital of Russia, and I was like, okay, I want to work as a visual effects artist. And they started like, I saw a video on Vimeo highlighting interview with like the top like 7 film studios out there, visual effects studios. And there were all these supervisors talking about the visual effects work. And I was like, those guys are cool. Like, I want to do stuff with those guys. So I went to Moscow and like every day I would like write up the name of the like supervisor guy, the company where they work, like all the information I can gather. And I would just go there and like knock the door and there'll be like a guard or some receptionist. And I was like, what do you want? I was like, well, I have an interview with this person. I have an appointment with this person. And they'll be like, about what? I'll be like, about employment. And they're like, oh, okay. And like, let me call. Like, and in every single case, I was able to get the appointment with that person, which at the end, like, I thought is like fascinating. I was like, how did that really happen? But like, they look at my portfolio, which was just homegrown collection of images that I made. And they're like, And then every time they were like, do you know Houdini? I was like, what is Houdini? And at that time, I would come home. I was like, okay, what is Houdini? And I started learning like what is Houdini Effects. And Houdini Effects is a node-based software. It's basically Touch Designer started by 2 brothers and Houdini, and they started doing this software for 3D graphics. And then one brother wants to do real time, and another wants to do more like for offline visual effects and more like you hit render and you wait for an hour. So they split the companies, but the core of the software stayed the same. So Touch Designer and Houdini started as the same software, which is, I think, is interesting. I started learning the software and I got a job in a small visual effects company, which was 3 people. And one of those people was this guy, Anton, who was like smarter than me in that way that he like knew how like computer, he can write script in Python and he can write some simple shaders and stuff. And I was doing just pure art, like doing sculpting and just like drawing and everything. But like when you work in the real production, there's a lot of tasks that come up. Like a director give you like shots, and there's like 10 shots, and maybe like effects are very simple. You like do all this effects, and then it's like you need to render all the shots like into image sequences, and then those image sequences need to be assembled into files, and then like a short preview needs to be generated from the file. There's all this, and then you have 10 of those. So you do all this work in 30 minutes, but then like for another 2 hours you sit there, click the buttons until one is like wait until one's finished, and the computers were not that great that way you can spin up all these jobs and everything. And this guy would be just like, oh, you can write like a Python. He just for himself he would write a 5-line Python script and like automate that and go have lunch while I'm just sitting there. I was like, well, if he can, and I was like, can you share the script, right? He shared the script and I would run in my machine and also go and drink coffee instead of sitting there. And I was like, wow, that's kind of fascinating. And if he can do 5 lines of Python, surely I can as well. So I started like looking into that a little bit and messing around. And then after working for some time, I went to San Francisco to study more seriously visual effects and animation. And there in school, I was like surrounded by all these artists. And there's always like, again, it's the same needs. And people start asking like, hey, can you do like this tool we need to do? Oh, can you do this thing like we need to automate? Because everybody is an artist and there's nobody to do that. But I'll be like, yeah, I can. And I'll go and figure it out. And so this was kind of just my way of like slowly going and learning that. And also being in San Francisco, like surrounded by like everybody, like all these people, like in San Francisco, even dog knows how to write JavaScript. That's what I'm saying. Used to say.
They did Haagen-Dazs did bus ads on BART that would be like in JavaScript.
Yeah,
like,
that kind of stuff.
It's like so endemic of the area.
And it just also like was a period like all the jobs are high paid. There's all this amazing smart individual who doing code, and I was like in this house of 7 people. This is where I actually met Snake as well, and like you know, I'm like just like kind of excited and fascinating. One of this guy in the house become my mentor. I would like come to him and I would like implement my button and like JavaScript like on the page and like very silly stuff, and I would show it to him and he'll be like genuinely really like, excited about it, and then like he will show me like some stuff, and he's the one actually who told me learn Bash, learn command line. And I would start, but it was kind of inevitable because once you start messing around with this, you like on that path with like just learning this nitty gritty. And like one of the bullet points that I highlight later about the command line, by like learning that, you actually will like expand the knowledge of just fundamentally how computer system works. So yeah, that's sort of like a highlight in my story. I want to just the real baseline there is that how I went from complete noob and artist into being able to get write software. And today I do jobs and where I write full stack software in variety of different languages, starting from Python, Go, JavaScript, TypeScript, Elixir, and others. So, but how do computer actually work? So it's all start from the simple component which called transistor. And transistor can be thought basically as an electrical switch. Everybody understands what the switch is. So you have a wire, you have a switch, and then you can turn it off and you can turn it on. Basically cuts the wire, right? And that's all the transistor is. If you look at this image on the screen, this is an image of actual transistor, how it can be found in electronics. What's notable here that it has 3 legs. And so the leg 1, 2, and 3. So the wire connected to leg 1 and 3. And if you apply current to 2, you can break the connection or restore the connection. And that's basically the fundamental principle of the transistor. And in the modern computer system, you have billions of those little transistors. And they're not actually physical. They actually printed on the silicon die through some chemical process, like kind of like a almost 3D printing, not like a light printing on the die. And so this way people can like design those dies and have like billions of those transistors arranged in the clever parts. So multiple transistors can be arranged to form what's called a logic gate. So, and the logic gate is a little bit more of a complex thing where like you have a current on one end and you can say it's like, oh, is it true or false if 2 other pins has a current or not? So it's like this, it basically become representation of Boolean logic in algebra. So you have all these true tables, like if this is true, this is false. If this is false, this is true. And depending on the gate, those true tables can be different. And so from those logic gates, you can compose more complex structure. And the structure can do a basic mathematical operation, like for example, adding 2 numbers together, or subtracting a number, or multiplication. So once you have those things built from this, and so I'm not going to go like into example of actually explaining how it works. There is this, let's go to a slide, this one. This is the book that start from this very basic example of transistor, and this actually show you step by step in a very simple form. It's not mathy at all. It actually has example from the real world. It shows you how you can build something more complex like a logic gate and memory cell from just a simple switch like this. So highly recommend at least like look through it, maybe first 30 pages. The first 30 pages has like all of that information like laid out in a very clear form that if you follow along, you'll be able to like have a complete picture of that process, how you go from the transistor to doing mathematical operations. And what's notable that it's interesting, which I didn't know myself until I read this book, that the memory cell can be also constructed from the transistor. So you have the switches, and what the memory cell is, it's like you say, I want 0 here. And the thing, until there is a current, it remembers that there is a 0. And so this is how like you have RAM in your computer.
Is that considered like a locking transistor? Because usually with those types of transistors, there's like a mechanical shape basically inside that keeps it locked once you put current through it versus not.
There's nothing mechanical in a modern transistor, and that's
Well, yeah, in modern transistors,
Yeah.
but I don't
But
know
yeah.
if the electrical version
Yeah.
of it works.
Like in physical world, it's easy, right? You have if you think about the physical switch, you switch it and it stays the same. So in a way, it's like hold the state. But in electronics, it's a little bit more tricky because if there is no current, there is nothing happening.
Yeah, there's nothing keeping it in that
So-
state.
And the first computer, by the way, were mechanical computers. There's all this like gnarly system that people design with the cog wheels and levers that would able to compute simple operations. But the problem with the system is that you need a lot of transistors to actually be able to represent complex mathematical operation. So and that's why the first computer that were built not from the transistor but from those lamps that basically can perform the same function as a transistor, they were like huge, the room size, and they consume a lot of energy. And the moment that people figure out how to get like from big to small and able to put like thousands of those and billions on the die, this is where we get this like a renaissance basically of computer world. So yeah, that book. Couldn't figure out how to, like I was searching for all these diagrams and everything, and they all like too complicated about CPUs. So I drew my own. It's very
It's beautiful.
it's very contrived.
It's communicating exactly.
But I think it's communicated exactly like the essence of the CPU architecture, basically. And the CPU architecture consists of the following. You have, if you've never seen the CPU is just like this square sitting in your computer. Sometimes it's small in your phone. Sometimes it's a little bigger.
Usually it says Intel or AMD on it.
Yeah, it's like just a black square, and you don't know what it is, and it has all these pins, like hundreds of pins in it. But inside of it, it's like this micro controller is printed on the die, where it's just a bunch of transistors arranged in a very clever way by very clever people. But what they represent there's all these little like areas on the CPU, like highlighted here. There's literally physical areas made of transistor that can do some mathematical operation. So like in this diagram, you see, for example, an add operation will be some area on that die that can add two numbers together. And that area also has an address that you can, which is important because you don't want to just have a black box that you cannot control. So you want to be able to like have an input to your CPU. And you do it by specifying an address and specifying like the values you actually want to add together. So, and it will be like a bunch of those areas that say like multiply two numbers, move one number from another. And one thing that I didn't mention before, CPU also has a memory implemented the same way with the same transistors. And maybe you didn't know, like there's a RAM. It's usually a separate module. It's a lot of memory. But the CPU itself also has a memory, and that memory is called registers. It's usually a very small amount of memory, although modern CPU have more and more of that. And the register is just basically those cells made from transistors that can remember certain values while you're doing those operations on the numbers. Because if you imagine, if I want to do an operation, like let's say I want to like add 12 to 2, right? So first I need to kind of store those numbers. Then I call the operation. Operation is like, oh, okay, you have a number 12 in EAX register. And EAX is just a pure name here, as well as this like weird numbers that came up, 0x. Those are just, it's irrelevant really. So EIX, EBX, and ACX, but this is the actual names that modern CPU often use. It's from, yeah, it doesn't matter. So, and you put values in the cells, and then you call the add operation, and it can take those two numbers and produce a result. And this is basically the answers of the how CPU works, and this is how you can get like call your mom on the other side of the planet, and from that simple logic, it's just scales up and like, you know, adding those numbers. Of course, there's a little bit more abstraction how you get from like a simple mathematical operation into like, you know, a picture on the screen, right? So those are domain specific sort of scenario, like how do you form a picture? What's the picture in the computer screen? So we're not gonna look into that stuff, but hopefully there's a little bit of, give you a little bit of idea what like, oh, you just have this like switch and like, so you'll see why this is important in the next slide. So for example, as I showed you, we have these addresses. Actually, I should fix that to that address thing. But computer program is nothing more than just an instruction that called those mathematical operation that encoded in the hardware with just some values that user usually provide. So, and when you have a computer program that is compiled to machine code, those instructions will look something like that. So you have an instruction which will correspond, let's say, to this one. Let's say it's an add instruction. And you have two values. Well, in this case, multiply this one. So, and you tell CPU, multiply 2 by 2. And this language this is how people used to code at the beginning. When they have the CPU, they're like, okay, they will have like a giant manual where there's like pages and pages of different instructions particular CPU supports. And people will type 0 and 1s, literally, and like 2 to just do stuff, like compute. And then soon they figure out, like, this is too hard. Like, how about we just replace at least those addresses with some mnemonics, just the words that human can read. So they end up doing this kind of thing. So where you say mult 2 by 2. And then this is just a simple example, but this is actual, and they call it assembly language, where they just replace it. So this is actual, maybe you heard about assembly before, but this is actual assembly code. This is a valid MASM assembly code. So can anybody guess what this code does? So few things to point out.
Well, I'm just trying to figure out if MOV is moved.
The EIX is remember the name of the register.
So you're moving that register's value or replacing its value?
The first one, yes.
First one, okay.
We're putting value 2 into an EIX store cell. We're just saying, like, remember that value.
Oh, I see. So, okay. So you're basically making a pointer. So you're saying remember this value, then multiply it with this,
Yeah,
and then add another value.
correct. So, and this, you see, it's like it's not specifying this, that it's multiplying this register, but by convention in assembly, I think the last value that you stored.
It's the stored value in memory.
Yeah,
so
you can just
implicitly, yeah. Okay.
But so all this does is just, it calls this instruction called move, which is literally encoded in the hardware level with all these transistors that are printed on the die, and the CPU does like, take this thing, move it to here, and then just store it. And then it's like, the next one, you call this multiply, which call this little multiply hard block on the hardware. It says like, oh, okay, I need to go this path, take this value from here. It's like literally physically happening on the CPU, and then multiply it by 4. And then you call add, which is like add is like, oh, you want me to take the value of this EAX thing, so it goes and look up this EAX and multiply it by 12, and so it produced the result. Now I have this computation happening, multi-step, and this is a computer program that would be written in assembly language, and the moment people did that, when they went from a machine code that machine can actually understand, because this is, you can just feed it to a CPU. CPU is like, oh, I know this address and I know the values. But when you replace all the instruction with human readable code, machine doesn't understand it anymore. It's like, what the fuck is move? So it's like, so you need a transcriptor that will replace those values with this code. It's basically like a human sitting with the manual and replacing that, like, oh, move, this is 0001111, right? So it does that, and that's piece of software called an assembler. It's just a computer program that basically replaces human readable words with machine readable codes. So, of course, that was, for a while, people was writing computer program like this. And it was, I did my assembly program. It's like a little terminal game. It's actually simpler than it seems to be, because there's not that many rules. There's only like move, multiply, but you can do a lot of things with those by just combining simple things. And you can call like other procedure, like print something on the screen that already your operating system provide. So for a while, people had done that kind of coding. All the old Atari games were written in assembly language. You can go online and look them up, and it's pretty gnarly. There's all these blocks of code, and you're like, how come people like really did that? Where this character, Mario character, jumping on the screen and all that stuff's happening. People at NASA did first mission like in assembly. All these modules for like lunar landers were written in assembly.
Famous picture of Grace Hopper with a bunch of volumes as taller than her actually, and she was like the main developer of development mission assembly.
Yeah.
Also, if you look at those chips that they used on those missions, like you can see because of like how they're tied, like how the memory is distributed in them. I will look up an image because this is a very big.
And so, of course, people don't want to sort of stop on that point, and they went and invented what's called higher level programming languages, where they sort of use the same idea of like, how about we start replacing certain operation and abstracting multiple assembly codes together into sort of higher level operation that humans understand better. For example, this is not a great example. I didn't have time to finish it today, but this is a piece of Python programming language's code that compute display a prime number within the interval. So, and you can see here, it's like you have a concept of like a variable where you can assign a value. It's the same like a idea of a register. But then you have things like if statements, for example. You can say, oh, if this value is more than 1, then do this, and then else you can like print the value in the screen. And this pretty much reads as a normal language, so English. So if we read this, we say for number in range. So, and then we have a range, which has a lower value and upper value plus 1. So for a number in range of numbers, you say if that number is more than 1, then you have another loop that said, again, for the number in range from 2 to the number, if the number is, what's the symbol called, Alejandro? What's the English word?
Ampersand.
For that? No, modulo.
Modulo, yeah.
But this is what I was talking about.
So they take a modulo of this, and this is 0, then they break it, and if it's not, they just continue and print the number. So basically, the prime number is the modulo of 2. Sorry.
Kif, this is the magnetic core memory. So this is like how memory was stored in the Apollo mission.
Damn.
Which is like pretty insane when you think about it. Because also, like, as it went...
That's a program?
That's the code.
I also want to show you.
She was the main developer.
So-
She printed the assembly code.
It's a little bigger than her.
For this whole thing that I just presenting, I have a document published that I wrote. It's basically an expanded version of this presentation with the title. And I just want to point out this image here. This is an image from Bell Lab around 1972. and those two guys are Ken Thompson and Dennis Ritchie, and they're sitting in front of this computer. This is a giant computer, and the way they write a computer program right now probably, and the way they interface the machine, you can see there's no monitor. I was like, how the fuck they see what they do? So there's a giant roll of
This is pretty gooey.
yeah, this is a giant roll of paper, but this is related to command line, right?
Yes, of course.
A giant roll of paper, and so literally they typing text on paper, then they hitting enter, and then something happened, computer program get executed, and they have an output result, which is insane. And those circles right here, those are what's called a magnetic memory. I think this whole block has something like few kilobytes of memory or something, and there is this magnetic, and those were probably also some sort of storage.
Yeah, that's the original hard drive, upper left. Those are what hard drives used to look like.
Mm-hmm.
Yeah.
So, but yeah, if you're curious and just kind of for if you want to look more what like this presentation is about, this is all the stuff that I point out, and this is the logic gate image.
So is it the size of transistors have decreased over time, or
Yeah.
a very large?
Yeah, and that's what caused the sort of revolution in the computing, really.
More expensive?
Well, along with other advancement in algorithm and architecture of CPUs, but
Yeah.
without minification of the size, you won't be able to, just from the energy perspective, if you have a giant computer in the room, it's probably consume a lot of energy.
Yeah.
Yeah.
So, because there's all this thermodynamic laws, like even electrical laws, like the thicker the wire, the more resistance you have on the wire.
Yeah.
So,
But yeah, memristors are next.
And part of the reason why, well, there's a law, the Moore's law, about
Yeah.
the limit.
Which is a theory, I want to point out.
Sure, I mean, it's called Moore's law. I'm just saying,
Okay.
yeah. But it's basically like, saying like, this guy was projecting where would we get stuck, making smaller transistors. And it turns out that even like something that we didn't even wrote about is that we are reaching the point where we're going at such scale that it's being like quantum interactions between the electrons that is messing up with the computation. So yeah, that's small.
all right. We are moving to a live demo. And I want to start with the point, kind of connecting this all together. Why is it relevant at all to what are we going to do right now and the interface with the computer? So on the terminal, and this is a computer terminal, you can all kind of like open it on your, like if you have Mac, you just press command and type terminal. That should open this similar window. It can be white or black. So is it big enough? Yeah. So any program that you can run in here, like let's say I can type these two letters called ls, which stands for list files. So if I hit because this directory doesn't exist anymore. So if I type ls, that's a command for list files, and that's list all these files. If I look at it carefully, I was like, oh, this looks like my files in my home directory. So if I go here, kif. So this is all the files in my home directory. So that ls command that I just typed, it's a computer program. And command line can be seen as just an interface to execute computer programs. And you can execute a bunch of them, and there's all kinds of utility, and you can combine them together into like a larger command line or even a script. And so we're kind of gonna explore it right now. And we're gonna learn just command by command, like a very simple series of commands that you can type to do useful stuff that you probably won't be able to do without those commands at all. You will have to download specialized software, often that is paid, developed by people, maybe have ads, all kinds of bullshit. So let me open my cheat sheet right here.
PC also has a terminal?
Who?
Just Macs.
Yeah, every
Yeah.
system has a terminal. And
Every
so
system.
what's important to understand is that, here, I have it here. that's why I said I didn't finish my slide, so I'm gonna do it from here. So what's the advantages of command line? And the main advantages is, learn once, use anywhere. So you can learn a computer program with graphical interface, and you might have this program on another machine or you might not. But when you learn command line, the principle of how command line works in that interface are universal across any computer, because they're so old that those guys in the Bell Lab, they were typing probably the same command, and many of them are unchanged. Like that ls command probably stay unchanged since like 70s. So, and the chances that those guys typing the same command that you would type today. So it's like, in a way, the ecosystem is very like rigid and old, but at the same time, there's a lot of sort of new computer programs that written today that has no graphical interface and that you can take advantage of.
Like FFmpeg.
Like FFmpeg is one of them, but we're not going to look at today, but maybe next session.
Sorry, for future.
Yeah. So, and because it's a text that you type, it's trivial to automate. If I can type and execute something, then I can type another thing and execute something and another thing. And now I can just copy those things and put it into a file. And now all of a sudden I have a script or a procedure that is reproducible. So I can just repeat it over and over again. I will show you an example of that in a second. So knowing command line will enable you for higher level customization of your operating system. Operating system usually have like settings so you can modify, but not all the settings are exposed. And often like to modify something is just not exposed in the graphical interface. And the only way to do it is through command line. And Linux kind of embraced this idea, and on Linux, a lot of things that you want to customize, it's all through command line. And that's why it's so scary as well.
Why is it
You
scary?
can fuck shit up. really
Because
easily.
like a lot of simple things that you would take for granted on Mac and Windows required command line interaction in order to change them.
Why it's intimidating.
Yeah, intimidating. So another, I think, huge advantage that often like not mentioned at all about command line, that by learning that you gain access to a large ecosystem of command line programs that have no GUI. And the reason why this ecosystem is large, because writing graphical user interface is hard. So imagine like designing all the icons, design interaction. This is a really hard job. And I know it myself because I build many user interfaces. And often for myself, if I need to accomplish a task on a computer, I write computer program without user interface, because like I don't care, I just need the job done. So, and it's a lot easier for me to maintain, because if you have all this interface, these constant things that you want to fix, this is a lot of work. So a lot of people write just command line utility that does something that you want to do, but there is no GUI. So, and if you don't know how to run it, you're sort of like stuck. Another feature that sort of not direct property of command line, but it's enabled via utility, a program called SSH. It basically become ubiquitous in the modern world. So, and all the developers, pretty much all developers use it. You can access any computer anywhere in the world remotely. And pretty much any machine that is on the cloud has this interface installed. And so by having, and you see all the hacker movies where they're like, I'm in right now, I'm on the system. So all they're doing, they're accessing this machine remotely through a command line interface. And then they basically have a full control over the machine. You can copy any data. And we also go in the future session, in the next session, we're actually going to do that. We're going to learn how to control the remote machine, how to copy files. We can have like machines on the cloud. I can access your machine in the classroom, like all this like amazing stuff. It's a mind blowing. And because it's all, again, the second property, it's automatable. I can now run a script that like, let's say, copy files from like all your machine at the same time, or like execute a task on all your machine. Like let's say I need to render a Blender file, or like something that, or like a compute bunch of images for AI or whatever, right? So I can just click one button and the task gets sent to everybody, and then all your machines start like, just spinning and like doing the job, and I get all the results in the file to NAS, for example. This kind of stuff. And those are trivial. It's like 3 lines of code, and it's amazing. It's like really like empowering.
I remember hearing a story that somebody left their laptop out, and you went and
Oh, Maggie.
No, it was
Flow.
past years.
Flow,
and you
yeah.
went and set something up so you could control their computer, and then you send some message or
Don't
something.
leave your laptop.
No, it wasn't. I wasn't controlling, but I basically installed a program that say poop in the random intervals. His computer was saying poop.
A stoner would get mad.
So, and another property of a command line, by just learning the how to interact with command line, you will better understand how a computer works, and that's fall from the just historical nature of that and like the low level of that interface. What I also personally like about this that it's a no distraction environment. Often if I do it in a command line, I have like a full screen.
Oh my god, that's so
And it's
cheap
like-
of you.
Nothing's going on, and it's like, you know, you just like, it's you and this black screen and the text and the computer, and the flow is just like, you know, type, enter, type, and there's nothing else that could happen. And like that's kind of like, once you get like a little bit into that, it become kind of interesting feeling. And also, who don't like to feel like a hacker? It just looks cool.
Every day. That's my only goal.
And another property of that at work, like if you work in the office or ever work in the office, you know, you're like, oh, I need to open like web and browse some things, like read some news, but you're not gonna do that because everybody's looking at your screen. But if you have a terminal open, there are programs that allows you to read like news feeds, even Facebook messages and stuff. You can have this terminal with a bunch of text going on and looks like you're fucking mad into some crazy task and people pass by. And then all you're doing is just reading Facebook messages.
Useful.
Yeah, I mean, very practical. Very practical life hack. So, okay, we learned already one command. It's called ls, and it's called list files. And one thing immediate to point out, so I don't actually need to type it. If I type it already, I can just press an arrow on my keyboard. And that's list through the history of all the commands I typed before, up and down. So if I type up, I'm back to this command. I can just execute it again. So, and by default, if you open your terminal, you usually end up, it's what's called in your home directory. And that's directory. I'm going to constantly open Finder just to make it tangible for you, that you don't look just at the text, you actually look what you see in the graphical user interface, because it's all one-to-one sort of mapping. So right now I'm in the skip directory, which is my home directory. And so I'm listing all the files in there. So how do I know that I'm in this directory here? There's another command called pwd, and that stands for present working directory.
I thought it meant print working directory.
Yeah, so if you type that, all it does, it just prints where you're at. And it said, you at user kif. And in fact, I am at user kif. So if I want to move somewhere else in any other directory, let's say I want to go to download. So I have download directories here, right? So I can type it. I don't have to type the whole world. And one thing to point out, it's case sensitive. You cannot type download lowercase, so that's not gonna work. So pay attention to lower and uppercase. So if I start typing download and I hit tab on my keyboard, it's autocomplete.
To the last point where it becomes unique. So if you have like downloads 1, downloads
If I
2,
type
download
D and
3,
hit, look, if I type D and hit tab, it will list all the possible possibilities that I can type, which is also handy. So if I like do
What was the you just said to list all possibilities?
tab.
Just if there's more than one choice.
Yeah.
Mhm.
If it's the only choice, there's only one D, then it'll go in, it'll be the whole thing.
Type
But if there's
DE.
multiple choices,
It'll
then it's
show
gonna
it.
tell you which one.
Does anybody who like don't have terminal open who wants to follow and have some struggle to do that? Everybody good. Cool.
My computer.
So
Try it.
so I do CD and then I do space and then go download. Now it's actually displaying here. I said
Yeah,
like I'm
yeah.
download. So the first thing I like to do when I go to a new directory, I of course like to look what's inside. So I do ls, and I have a crazy amount of crazy files with crazy Russian names in there, but we're gonna ignore it.
A lot of movies.
I have a question or a comment.
Yeah.
for people. Does everybody have Macs? Because I think you have Windows.
Yeah.
It's not exactly the same for.
Exactly.
Or-
Yeah. On
but
Windows,
like-
slightly different. Principles are the same though.
I grew up with all this stuff, so I'm good.
Okay. So it's only you with Windows right now.
about me?
I have Windows.
Oh, okay.
You have Windows also.
I have
But how much command line? Who has command line experience? Or who doesn't have command line experience?
I don't have.
Little bit,
You don't have any.
Zero.
little bit.
little bit.
Show me your LS.
Show me your
Show
LS.
LS. No.
So show me what you
So
have.
Well, type LS and hit enter. There you go. Yeah, this is your files.
Good.
Cute.
Now try to do CD space and then try to go somewhere else in any of those places, right, that you have listed.
Yeah.
Like downloads, I don't know.
Yeah.
And of course, I can scroll up with just normal scroll. So I have shit tons of file on my download, so there's a lot of stuff, but that's come useful to demonstrate some other principle. So let's look at my notes.
Does it, are you, is this bash? That,
Yeah,
okay.
this is ZSH technique. So what Marcipan is referring to, so the program that you see, the terminal is the program itself. So it's provide you this window, which is also graphical user interface and all this line. So it does something. That's called terminal. But inside the terminal, there is what's called a command line interpreter, and that's also another computer program that makes sense of like how do you separate like the command that you type and the space and what's the arguments to the space. It does all this kind of like logic and machinery behind it. And that program usually called bash, born again shell, or it's called ZSH, which I don't know what it stands for. So on modern Mac they recently switched to a shell called ZSH, but it used to be bash. I like bash. It just sounds cool.
And all Unix will builds, whatever you call them, will run. You can run bash through the command line interface.
Yeah.
But like, there's nuances depending on.
I wouldn't worry about it.
Okay.
Those nuances are so. I actually never met them in my personal life ever. Even between ZSH and bash, I wouldn't worry about it. This is really nitty gritty. So we're trying to get through like, basic. So I have all these files, and now like my screen full of crap text. So I want to get rid of that because it really makes me anxious. So the way you do it, you press Command L on Mac. Actually Command K. That's clear the entire screen. So Command K, clear the entire screen. Let me put that the shortcuts.
Man. Oh.
On PC, do you have
So what?
he needs to have a WSL open though.
Yeah. So
Can you help him?
And what's the difference for the
Okay.
Windows
So, anyway, so PowerShell is running. It's different. It's
Mhm.
not bash.
Yeah, we
There's
don't
some
want it.
similarities. Like he said, because like CD and LS, like they go back old, so those will work, but not everything will work. So this actually isn't bash, and so WSL, it's called Windows Sub.
He might not have it installed. If he doesn't, we can install it after I
But
finish
we
with the
also
demo.
could run Cygwin. We can download Cygwin. or
No,
something.
no.
I think it's
Modern
easier to-
WSL is better.
Yeah, but don't you have to install it?
Both cases you have to install it.
Okay.
Okay, Massipan, doesn't matter. We can help him after I finish the demo.
I have to.
But we should just start the installation.
Okay, I can.
Like maybe the
So
App
clearing the
Store
screen is great. I do it all the time. So, okay, what can we do with this ls and how can it be useful? So, because if I do ls, I have all this stuff which I actually don't want to see. I want to maybe see only specific files. Let's say I only want to list all the images that exist in this directory. So the way I can do that, I type ls space and type what's called wildcard, which is the star. And then I type dot and I type image extension. And that's just part of the file name, right? So if I look at my downloads folder here, let's see this PNGs, and you have a JPEG. And here, it's like this is user interface. Okay, like how do I list all the JPEG images? Well, on Mac maybe I can use this. That will work. But here's I have like a JPEG image. It's called .jpeg. So what that star means is basically it's anything that comes before that like doesn't matter. What I only care about to match the last part of that name, and that in this case is a JPEG. So it could be anything. So I can match any part. I can do like this. This file has a pixel, for example, but let's do just JPEG. So if I do that, you see the output of this, all the images inside of download directory that has in the JPEG format. That's pretty dope. So what can I do with that? Useful. This is okay. This is immediately sort of like useful step. Let's say you have a directory with a bunch of files, and you need to sort those files and move it to a directory. So let's say I want to move those files to a directory. So I can create directory directly from the terminal. So a command for that is mk dir, stands for make directory. So I type that, and then I say images. No, let's do pictures. Pics. So I do that. So seems like nothing happened. But if I look in my download directories, here you go. There's a directory that named pictures. So now what I can do, I can go up to history, up R a couple times. So remember this ls command? So, and that's the argument to this command, which just this bunch of files. So what I can do, I can replace this command with a command called cp, and cp stands for copy. So this part didn't change, so I'm still operating on those JPEG images, but this command has changed. So if I do cp JPEG, and the cp, of course, it's a copy command and say, give me a file to copy input and the location where to copy to. So, you know, like normally, you select the file in UI, you click copy, you go to directory, you click paste. But in this case, it's just all done in one command. So I say, copy all the images that match JPEG into directory name pictures. And because I'm in this directory, so I just type the name of the directory. So I do that, it's execute, seems like nothing happened, which is good. So the ideology of Unix command line interface is that if command doesn't produce any error, it should not produce usually any visible output unless asked. And that leads to this kind of clean interface. Because imagine if each command print like, oh, I'm copying this file and copy that file, it'll be just too noisy, all this text you need to read. Annoying. So now if I go to this picture directory, now you can see I have all these images that have been copied from my download, only the images, into this directory, which is dope. So that's one thing you can do. Let's see. Yeah. So knowing that, let's look at like what is that automation I was like sort of raging about. How can we do an automation? So if you open any text editor on your machine, I recommend to use VS Code, which is just a text editor. So if you go to your website, VS Code. So this is sort of modern state of the art. Redefine, come on.
Revolution.
So you can download this text editor for your version. I highly recommend it. It's just a general text editor, but it's also built for writing code and a lot of other stuff. But we're gonna use it in its sort of basic form. So in the terminal, I can also start programs from the terminal. For example, if I type code, which stands for VS Code, and I provided a file, let's say I want to make a file called sort files. So VS Code is a program that also takes those inputs, and one of the inputs take is the file that you want to make. So if I type sort files.txt and I click enter, so that's actually will open the graphical application, VS Code application, and you can see that it already has this file open. So now I can start typing stuff. So if I type here anything, save. So if I go to my directory, so you see this file was just created here. And if I open it, I see this text in there. So all we're doing is just modifying some text. So let's say I want to take this idea with the selecting certain files, and I need to sort them into a set of folders. So because this is a real mess here. This is my download directory. This bunch of shit. Let's say I want to take all images and put them into image directory. So what I will do, as we already know, oh, and by the way, here in the terminal, if you want to see the history of all the previous command that you typed, you can do, let me clear the screen. So if I do history and press enter, this will print last, I don't know how many, like 10, 15 commands that I type, but you can see more. But all I'm interested is like, okay, I did this ls JPEG, so let me copy. So I did this make picture. So I want to make, let me remove that picture directory that I made. That we're kind of starting again. So remove.
I really appreciate that we have your files within the history.
Let's fall. Hold on, some.
Very coded.
So another directory. Let's say I also want to get all the PDFs into its own directory, PDFs, and then let's say I want to do Blender files, Blender. So that's going to make 3 directories. So next thing I want to do, I want to copy, right, the file. So I'm going to copy this command. So I want to copy JPEGs to pictures to here. Then I want to copy all the PDFs files, PDF to PDFs, and the Blender files to Blender. So this is what's called a command line script, and you can execute it as a file, but you can also just, once you did it, it becomes kind of like a procedure that you can run, and save yourself time. Imagine like you have this task, you have to go to multiple directories and you have to sort files in all these directories in each directory. It'll be like very tedious and annoying. But what you can do here, you can just do cd, like, download, I'm ready and download. So, and then basically copy paste these lines in here. So let's try that. And copy paste that, press enter. It's going to do its thing. Basically it's evaluating each line. And let's see. So
Nice.
Sure enough, it's created all these directories called Blender with a bunch of Blender files that was copied from here. I have a PDFs with a lot of PDFs in there. And I have pictures.
Yay. So you're copying these files, you're not moving these files, correct?
Yeah, I'm copying because I don't want to mess up my, I would move them.
Okay.
Yeah. And the move command is just
MV,
MV.
yeah.
Instead of CP, you do MV and it will move them.
Isn't there a way also to do MV as copy? There's like a.
No, you use copy,
I
CP.
know, but there's.
Cut.
Might be, I
and
mean,
paste.
there's options.
Anyway,
No.
I'm pretty sure there's a way, and I've seen people.
Let's see, at some point I saw a file that I didn't really like here. Oh, it's my passport. Like, I don't like my passport laying around anywhere. So we need to remove it. So I'm going to do it from command line. So it was, what is called, Kirill. I think it's called Kirill watermark. So I can type RM, that stands for remove, and then start typing Kirill, press tab. So it will list me all possible files that are there, start with this prefix. So this is the file that I want to remove, this is my passport. So I'm going to select that.
Can you tab? You can tab also through them, right? If you keep hitting tab, doesn't it cycle through them?
Does it? Ah, yeah, it does. It just, yeah. If the list is too long, it's not practical.
I know.
So I go into RM space Kirill foreign watermark. Boom. The file is gone forever. It doesn't go to a trash bin, so you have to be careful with that. So it's kind of like remove forever type of thing. So what I like to do sometimes where, that's just a tip, when I'm working and removing a bunch of files through a command line, I like to do this. I make a directory called deleted. And then instead of removing that file, what I will do, I'll do move. So, and then let's say I want to do this image. What's this image? It's my parents. So I do move, and then I do delete it. So now the file is gone from here, but it's just in this. And by the way, when you remove file on Mac and it goes to a trash bin is just another directory that you just don't see. It's just still there. So it's just a convenient way. But now I can remove a bunch of files this way. Then I can open this deleted directory, kind of look through them. I was like, okay, yeah, this is what I want to remove. And then I will remove this directory itself. So for example, here I can do rm. And this is the thing I didn't talk. This is an argument called r. I will explain in a second. And I do delete it. So now this directory is gone and the file gone forever. This is just kind of a little bit of pro tip, I guess. So few more things. History, file command. Okay. I touched a little bit on this, but all that stuff that we just typed, the first part, all this rm, ls, make dir, those are just computer commands. And I want to like kind of sort of ingrain this idea that the computer command we just said that send this instruction to a CPU, and the computer commands are stored as like set of all the 0 and 1s that computer can understand. Because somebody wrote this command in the human language, and then they would compile those into the 0 and 1s through some other program. And so now this command's just on my computer. So, and you can see them. So if you do cd, on Mac it's in bin. So and the slash, if you do cd slash, this is what's called your root directory. This is where like you have a hard drive with all your files. Like you open your hard drive, that's the sort of the root. This is where it starts. And inside your computer, there's the same hard drive that you have an external one. And this is actually the sort of the root, which on Mac, it's like, it's kind of abstract to you. You never see it because all your locations are here. But you can still go there. So if I do Command Shift G, which stands for go right here, go to folder. So if I type that in the Finder, press slash, press enter. This is the root of my hard drive on my computer. So for those who didn't know. And so here I can do the same. Do cd slash, do ls. This is all the stuff. But interestingly enough, I see more folders because I think this thing doesn't show me some of the hidden files, which is also pretty cool that you can see this, because sometimes there's a hidden file you want to access. So the folder that we're interested in here is called bin. So we do cd, bin, and we do ls, of course, immediately. And this is interesting. Look at all these files inside. So if I open them in the Finder, and the way you can open any location terminal in the Finder, you can type open and dot. And dot stands for a current directory. So it's just a convention. So it's just basically referring to this directory. So if I do that, look at that. What is it? So there's a ls, there's a make dir, and you can see by the icon that it said executable file, and it's 100 kilobytes. So it's a computer program that people at Bell Lab, I guess, written in C programming language, compile them, and now this little program shipped as part of a Mac OS operating system. It's really cool. And in order to learn more about these computer programs, Unix and Linux-based environments have a utility called man, which stands for manual pages. So, which is yet another computer program. So, but this computer program can show you help about any other program. So if you do man ls and hit enter, this open manual page for the ls command, and you can see that the name say, oh, list directory is content. And that's what it does. But you can also see that there's all this like weird things starting with the dash sign. So those called command line arguments. Because it would be boring if we have a command and the only thing that we can do, like just one thing that it's list files. It would be interesting to like, you know, like in GUI you have options. So you have a tool and maybe you have a different variation. You can go to like a brush in the Photoshop. A brush has a size, it has opacity, it has all these parameters. And that's what makes brush interesting. For example, in Microsoft Paint, the first version, you only had 3 brush sizes, so you cannot really specify. You can select brush 1, brush 2, brush 3, and that's really boring. And so same principles in here. Any computer program that you can call in terminal usually accepts some sort of parameters that modify the way this program is run. So if you press Q to exit from this, that's also common. Because now, like if you see, we're stuck in this view. And like there's no, if I press enter, it doesn't exit, it just goes down. So I kind of stuck. So when you're stuck like this, often like you press Q. And Q is for quit. So let's exit that thing. So let's see what we can do with ls. If I do ls and I do -l. So that's a parameter to ls. If I do this, you see that output of the ls changed, and now it's output this list, which still has a name of those files in there, but it also has a lot more information on the left side. I'm not going to go into detail what this information is. Just quickly mention this specify basically a permission. Like sometimes you have this problem where you try to access files, like permission denied, you can't access it. So you can see here that this letter stands for write, execute, and read. And there is the 3 for each category, and there's 3 categories. There's user, there is a group. No, wait. There's an admin, there's a user, and there's a group. So this sort of Unix decided back then when they have big machines, like there are gonna be only 3 categories of people. There's like a user, it's your account. There's like an admin who administrator the computer who can do anything in this computer, and there's a group that can contain multiple users. So that's what this permissions signifies. And you can see the interesting part about those files that have write, execute. So this is specify who the user is, and the root is the user that usually created by default in every computer. And it's just, again, by convention, the administrator on Linux will call either root or admin or something like that. And this is some weird group that, for some reason, this user belonged to on Mac. Who knows why. And this is the size of the file in bytes. If we don't like that in bytes, which we don't, because it's really not human readable, you can type LSH and LH. And H stands for human readable sizes. So you can see now, I can see, the bash is actually like 1.2 megabytes. And what we have? ls is pretty small, it's only 150 kilobytes. And we also have I think it's a creation date of the file.
Root.
Which doesn't have a year for some reason, I don't know why. But so, how did I know how to specify, how to specify this arguments? So by reading the manual or just Googling. But in the manual, if you do man ls, so if you scroll down and see, what was it? I did, let's find L first. Here it is. So this argument L, the lowercase letter L, lists files in the long format as described in the long format section below. Well, great. Let's do find H. Use H. When used with the L option, use unit suffixes byte, kilobytes, megabytes, gigabytes, terabytes, whatever. So, but usually the stuff, you just go online and you just search like how can I display these files, and then they'll be like in bash, and there'll be a command or in command line in Mac. So. Or ChatGPT is also great answering those questions and stuff like that. So kind of want to show like a little bit more powerful utilities that we have, because those commands are pretty basic. They just kind of make you like navigate around, do stuff. But one of the most more powerful utilities is called find command. And the find command, as the name suggests, can search for files. And it can search it across multiple directories. So you can search your entire computer for a certain file with a certain name, which is super useful, because sometimes what I often find when I use this kind of stuff, I don't find my stuff. And then because maybe it doesn't look through hidden files or something, maybe some directory excluded, I don't know why.
Or it's just shitty.
And I don't trust it. I came like, it was just shitty. I came to not trust any of the search
The
utility.
Windows policy
So let's say I want to find a file in my system. So I can do, well, actually man page for find is kind of awful because let's say I was like, okay, find Walker file hierarchy. Okay, great. That's kind of cryptic. But then I was like, how to use it? Synopsis. It's like this all this stuff. And like, I don't really understand that. Like, it's really hard for me to understand what the fuck is it. So this is a good way to Google something. How to use find command. Just as you know, because if you move to exercise now, this would be useful for you because the exercise assume you have to Google some stuff. So if I scroll down and I can see, okay, find, and it said path, option, expression. Okay, this maybe means something. I want to see an example. Okay, here's an example. It said find, option. Okay, here it said find. This squiggly line means it basically means a home directory. So if I do cd and I specify that what's it called, tilde, it's usually on the corner of your keyboard, and I do cd and I do present working directory, that's mean I'm in the home directory. So all that means is that it basically point you out to your user home directory.
I think another convention says CD takes you to your home directory.
That's also true. But here,
It's the same idea.
I'm just explaining here they sort of find.
Yeah.
They basically search in the home directory. I'm not going to use that.
Definitely ignoring, not putting anything wouldn't work.
So let's say I want to find inside my home directory, which is users kif. This is my home directory. I want to find, and then the parameter name is accept. I want to find all the files that starts with anything. I put star. Has Bjork
Yes,
in its name.
we know it's true.
Yep, it's true.
How many will we find?
How many?
More or less than 10?
More.
Yeah, I think more too.
And I also want to file to end with anything. So basically that Bjork can be anywhere in the file name. As long as it match anywhere, find anywhere in the file name, it's going to output this. So, and it's going to run. It's not that many. And so it goes through a permission denied. This is kind of stuff I was mentioning about permission. It's the permission denied that I cannot really access these files. I want to ignore them. I'm going to type something that I'm not going to explain, but I will explain actually. So any command in Linux output what's called a standard out and standard error. And those are just basically files on your system that exist. You can also find those files. On Unix, it basically sends whatever output of the command to those files. And system is programmed such a way where this files has this output in it, you're going to print it on the screen. That's how it works. And if I do, can you do echo to 1? Let's do echo. Echo is just print stuff on the screen. If I do echo hello, so it just prints it. But that means that string was sent to this register. I wonder if I can do echo. Well, it just disappeared. Okay, we're not gonna get into
I
it.
think
But
made a file named 1.
oh, I did. Yeah. Okay. Anyway, so what I want to do to not output it, I'm saying everything that from the file register name 2 will be redirected to dev null. And the dev null is another file on my file system that basically discard any error output. So this way, the find command will just output all the files and will ignore the errors, which is a cleaner way.
Wow, only 3.
So while this is happening, it's still running. So as you imagine, there's a lot of files that it can need to go through. We can. It found this file which named Rome. This is actually my notes, and my notes I store in just a text format in my computer, and this is just a note in a text format.
Date 2023 September 20th.
Yeah. So we can see what this note contains. So if you do code, and I paste this path to that node, I can open it in the VS Code.
Oh, interesting.
Yeah. So this is my notes of watching Bjork Iceberg YouTube video. That's just 2 hours long, and I'm making a bunch of notes about it. I spoke to Hinata, and she's like, "Oh, I'm a big Bjork fan." I was like, "Oh, me too." I was like, "Do you want to?" I was like, "Let me show you my notes," and she's like, "Oh."
I'm not that big of a fan. After all.
But basically, I went to all this tangent of all these bullet points and watched every single video that was in this thing. But I think this video is relevant. And this is actually the first one. We're gonna watch it. If you haven't seen it, you gotta see it.
The last one?
No, Bjork TV. Who's seen that video before? You haven't seen?
yeah.
No
Oh,
way.
is this when she describes the
It's
TV,
great.
like the inside of a TV?
Yeah.
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 That's a classic.
Well, this one is 4K upscale. Let's
Yeah.
watch
Oh,
that.
shit.
Fuck yeah. 1988. This is yeah.
Hello, it is Christmas time and I'm sitting here by my TV. I've been watching it very much lately because I'm on a holiday and I've been seeing all those programs about all sorts of things. About Icelandics being very happy about Christmas, very gay and also very serious and spiritual, and also seeing Icelandic comic people making jokes, which they are very good at. But now I'm curious. I've switched the TV off, and now I want to see how it operates, how it can put me into all those weird situations. So
How does it?
it's about time. See.
It's the head of the guy.
This is what it looks like. Look at this. This looks like a city, like a little model of a city. And all the houses which are here, and streets. This is maybe an elevator to go up there. And here are all the wires. These wires. They really take care of all the electrons when they come through here. They take care of that they are powerful enough to get all the way through here. I read that in a Danish book this morning. This beautiful television has put me, like I said before, in all sorts of situations. I remember being very scared to it because an Icelandic poet told me that not like in cinemas where the thing that throws the picture from it just sends lights on the screen. But this is different. This is millions and millions of little screens who send a light on you, some sort of electrical light. I'm not really sure. But because there's so many of them, and in fact you're watching very, very many frames when you're watching TV.
Like this comment.
Your head is very busy all the time to calculate and put it all together into one picture. And then, because you're so busy doing that, you don't watch very carefully what the program that you're watching is really about. So you become hypnotized. So all that's on TV, it just goes directly into your brain, and you stop judging if it's right or not. So you just swallow and swallow. This is what an Icelandic poet told me once. And I became so scared to television that I always got headaches when I watched it. But then later on, when I got my Danish book on television, I stopped being afraid because I read the truth. And that's the scientific truth, which is much better. You shouldn't let poets lie to you.
We upscaled it.
What the fuck did I just watch?
Wow, back to command line.
Rosh is
What a
experimental.
But so actually that Bjork file is not the only note that I have about Bjork, and it would be nice to have a way to find other nodes that I have with Bjork in it. And so there's another command. Well, let's go first to this directory. I go cd users kif rom. And this is where all my notes are. I have like a lot of notes here. So this is all the text files in here. So now I'm in this directory. I can use utility called grep. I don't know what it stands for,
When
but
did you use grep first time?
huh? So the grep utility allows me to search for text, but not only in the file name, but inside the file itself. So it will open each file and then go line by line to the file and see if the text match my pattern input. So what I would do, I'll do grep in the current directory again. I specify the dot, and then I specify what I search. Let's say chart. And here, notice that I'm not specifying those stars because grep by default search anything that include that keyword regardless of that. So let's do that. Now it said Bjork no such a file or directory. Well, I think I actually the location is the second input to grep. So the first input, it's important to the order of the input. So for some command, of course. So if I do that, it said it's a directory. So what it's trying to tell me with this error that I need to use an option to grep called R, which means search within directory recursively. So it will search all the files within the directory and any files within any other directory that within the directory. So it just goes on and on. And that's super useful because you have like nodes or some archive and you want to find certain document that you're searching for. You can execute that in the directory and you'll go through all the files inside of every single directory and you'll find that document within that text in it. So if I do that, it runs pretty fast. So it's already completed. And what I can see that there's these two files that we already examined. That's the same node that I just opened. It's contained the names Bjork. And if I look at it, it said
Cremaster também is a good one
Bjork
for us
partner.
to see.
So if I search here, what's it, partner? Yeah, you can see that it found this word, Bjork. But it also found. Did it find? No, I actually didn't find any other files. Let me search within not just my notes directory, but my entire home directory. How about that?
Yeah, because
Yeah.
I'm really suspicious. of
Users,
this
kif.
local.
Yeah,
Maybe it's also because of
uppercase. So I'm going to add I, which you're going to ignore upper or lowercase. So it's going to match either upper or lowercase. So I'm going to search for that and see if it works. That might take a while because there's a lot of files and like as you imagine, you open each file and goes through this line. But on the modern Macs, it won't take actually that long. You can go through your entire hard drive maybe in like 5 to 10 minutes. And that's sometimes often useful because I sometimes lost some file. I remember certain words in this file and I have no idea where it is. And I ran it over the whole thing and just wait for 10 minutes. And I was like, here it is, it's the file.
So you do that and you go make a copy.
Yeah. So while we're waiting for that, let's look at I think we're moving to the exercise section. Let's see. Yeah, I'm pretty much covered everything I want. I think this is more than enough introduction. Hopefully there were some interesting examples for you that maybe like tickled some of the problems that you might encounter with just like files and stuff. And hopefully it's not kind of seems accessible and not too intimidating. Just this basic idea like type the word, type the space, type the parameter, and then get some output, find your files, move your files around, that kind of stuff.
Okay. How do you exit once you have done the grep command?
I forgot to mention that. So if you run in your grep command and of course, it's like it's kind of stuck on this execution. So if you want to interrupt it, what you do, you send in what's called interrupt signal, and that's by default bound to Control C. So you press Control C on your keyboard, and that send a what's called interrupt signal to that running program, and the program will terminate before finishing. They give me some error, which I don't care about, but it's still running. I actually didn't try this in before. Oh shit!
Oh.
I think it found some sort of dictionary. What the heck was that?
Imagine you
Yeah.
have some clock
Surnames.
Portuguese.
Oh,
Use
look!
flores, a name.
Oh,
It
no.
found some library that include a list of surnames, and one of them is
Interesting.
Björk.
Whoa.
One of them's
But when you look, like you start looking for this kind of stuff, you find all kinds of weird stuff on your computer, and you'll be like, if you're curious, you can like go and start kind of like exploring this. But this printed this, and it's just not happy. It printed some. It got again is the separation not supported. Anyway, we're not gonna wait for that, but maybe we try to search for something else. Let's do CD, download. How about we try my name maybe? So we do here. Can we find my name here? Well, let's just do something that we know that is gonna find. So for example, there's this README file inside the download directory. So if I look at this README file, let's see. Oh, it has this name ZBrush in it. That's a program for digital sculpting. I'll show you, it's cool. If you didn't know. The recently released version for iPad, I don't know how much it is. But it allows you to basically sculpt characters with the brush. It's awesome. Okay, let's do, okay, find ZBrush inside of my download directory, go. It's taking a while, I wonder how big is my download directory. Let's see.
Oh, no.
My download directory is 68 gigabytes.
Dang. Can we edit files from the command line?
We can, but I would not recommend it to do it as a beginner.
Okay.
Yeah.
I'm gonna stay after class because
Yeah.
I can't get permissions to do it in
VS Code.
VS Code and then save it on the WSL side.
You should be able to do that though. You
I
need
know.
to try to run it as the sudo. You know what it means?
I know what it means, but I don't know how to do that when I'm in the WSL interface.
Okay, while it's still running, we're gonna go to exercise.
My downloads folder is 381 gigabytes.
Oh god.
Dude, we tried that.
comparing. It's a lot of downloads.
Right, so this is
It's where all the music is.
Well, as I started, I would you can try find a directory with the files and try to either copy or move files with a specific extension or a specific name. Maybe you already have something that you want to sort out in your computer, some directory, gnarly directory you have. So try to create a folder in there and then try to do what I did with the copy command and move those files into a directory using command line. So that would be a first exercise. If you complete it, you can move to the second one, and if you didn't, then and you're stuck, I can come and help you. So the lecture of the lesson is done, so we're kind of in the workshop now. And the other exercise I have, make a script that create a project directory template that looks like this. You're also free to choose whatever exercise you like first, like it doesn't need to be in order. But this one is actually useful, and this is a similar project structure that I usually do. There's often a task, so I work on a lot of like media projects, and every time I create a project, I need to create all these directories, and usually you do it manually every time.
Yes.
So you can make a simple script that will do it for you, and all the commands to do that you already know. So, and then you can go to directory, copy paste, booms, and create all the directories in one click, sort of. Find a particular file in your system. Maybe there's a file. I don't know which file, but like trying to find something that maybe you lost or just experiment. This one will require you to do a little bit your own research. It's like find all files that larger than 1 gigabyte. This is very useful. If you try to clean up your computer, like why there's a file that's larger than 1 gigabyte? What's this file? Why is it on your system and where it is? So you will be, if you run this, you'll probably be surprised as like that you have some of those files. You'll be like, oh, I should delete that a long time ago. Find a file with a particular text in directory. Also super useful, how many times you have like a text document or some other document that you don't remember where you put. So that's what we're trying to do now here. Did it work? Oh, look, it found file in my download called RSS. RSS is a news feed. It's just a way to get news from the web. I use that. And it found a file that has the ZBrush word in it. So if I go and open this file, let's do on another terminal. Do cd download. So I do code, open this RSS. So this is this file that is found. So in the VS Code, you can just search normally as any other application. You press Command F, and then do ZBrush. Yep, it was right. So this file does contain this word ZBrush. And this is some RSS feed maybe I subscribe, or maybe it's not mine. Not quite sure. And on the Mac terminal, you can create multiple tabs, which is convenient. So you can press Command T. It's the same like in your browser, and just create a new tab. And you can close it if you don't need it. So the grep is still running, 68 gigabytes. It's a lot, I guess. I'm gonna grab some water right now. I'm gonna stop the recording as well.